Hello to the dear friends and followers of the channel. We have another project with ADHT sensor that is used to control temperature and humidity within defined ranges. We can define relay outputs for it and use them to turn on and off devices such as heaters, coolers, humidifiers, and fans. Or in other words, to control the humidity level in the environment. In the following part of the video, the functioning of the code we wrote will be explained. In this video, the relay outputs we defined are, as you can see, first the cooler device, second the heater, third the air dryer, and fourth the humidifier. The program written for this project updates the temperature and humidity value on the LCD every 500 milliseconds in order to control the relay outputs. We need a temperature and humidity range relative to the environment and the task we are performing, which is adjustable. For example, in this project, we have selected a temperature range between 25.80 to 27.30 degrees Celsius. When the ambient temperature is lower than 25.80, it means that the temperature is below the range we specified. In this case, the relay corresponding to the heater will be turned on, and if their cooler relay is already on, it will be turned off. To turn off the relays, I used an average point between the minimum and maximum temperatures. You can calculate the desired average temperature as follows. The sensor I used in this project is DHT22, which has a measurement accuracy of 0.1. The probability that the calculated average has to decimal places causes the program code not to recognize this number. To solve this problem, inside our code, we convert the calculated average number to a number with 1 decimal place. When the temperature increases and reaches the average temperature, the heater turns off and remains off until the ambient temperature drops below the minimum temperature. If the ambient temperature exceeds the maximum temperature range. In this case, the air cooler relay is activated. And when the temperature reaches the average temperature, the air cooler is also deactivated. In general, the code works in such a way that if the ambient temperature is outside the specified range, it triggers the activation of one of the two outputs. The code written for controlling humidity in the environment may differ, as changes in humidity in the environment may occur more rapidly than changes in temperature. Especially if you are using a humidifier device, this may vary depending on the device you are using. In my case, I have experienced this situation, so I have acted accordingly. In the humidity code, we calculate the average humidity range and then convert it to a number with 1 decimal place. Then, we add the average humidity once with the number 2 and once with the number -2. By doing this, we obtain another range, which I named humidity min off and humidity max off. When the ambient humidity is at its minimum value, the output of the humidifier device is activated and the ambient humidity increases. When it reaches the humidity max off point, the output is deactivated, and it remains inactive until the ambient temperature drops below the specified range. When the ambient humidity is at its maximum value, the relay output of the dehumidifier or the fan device starts to work to reduce the ambient humidity. When it reaches the humidity min-off point, the relay output is turned off, and it remains inactive until the ambient humidity exceeds the specified range. You can see that the temperature and humidity data are transmitted from the DHT sensor to the Arduino, and the Arduino displays the temperature and humidity values on the LCD using the I2C interface. And also, in the Arduino, The instructions related to the relay outputs are processed and sent to the relay, which ultimately activates or deactivates the relays. The required components for this project. You can see the wiring diagram between the components, which you can download from the video description and also from the Mind Factory Telegram channel. Let's go to connection and code. Please pay attention to the connection of the sensor pins to avoid damaging it. Let's open the file for the code of this project. If you have specific temperature ranges in mind, you can enter them in these sections for temperature and humidity so that the code can work according to these ranges. After making changes in the code, select the type of Arduino board you want to upload to from the board option. Under the Tools menu, also, choose the processor type that is on your Arduino board from the processor option. Then, select the port to which your Arduino board is connected. And finally, click on the Upload option. After uploading the program, you can open the serial monitor in the Arduino software and set the baud rate to 9600. Then, you can observe the average temperature and humidity values that you have entered. Thank you for watching the video.